Where did we leave things off, by the way? Let me just go here.
I think we had
Um,
all the classes, if
mm,
I'm not mistaken.
okay, yeah. I think we had done all the classes and we, yeah, briefly talked about inheritance and extending stuff. Um, and let's go back here. I think, yeah, we talked about store item extends get vendor. Da, 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 da. It should also include a method get vendor name that returns the name of the vendor if set, unknown if not. So we had extended item on store item. I think that is what we had done here. We had talked about overriding. I don't
Mhm.
think we had actually done anything yet. Okay, so let's start with overriding, which is where we were in our previous lesson. So the concept of overriding a function simply means that your subclass
Mhm.
is actually re-implementing or providing its own implementation of the same function that exists in the base. In this case, print details. Now, if you look at print details in the base, you had done it like this. You print the product name, ID, and price. Now, store item would want to print name, ID, price, and the vendor name. So if we go back to um, store item and we go into print details, we sort of like want to do exactly what item is doing, which is this. The only
Mhm.
difference between the implementation of print details in item versus store item is that this one on top of this should also print the vendor name, which is it should do something like vendor, vendor, and then put the name of the vendor here, right? So if you go to store item, you know that the vendor is here. So we just want to get the name of the vendor. So we want to call the get name function of our vendor.
Mm.
So we can go back to store item and say this would go vendor dot get name. That's how we print the name of the vendor, like that. Now the question becomes, um, how then do we? Let me just do this quickly. Okay. How then do we handle this case where the rest of the items that we want to do or part of this function is exactly what the one we are extending is doing? The only different
Yes.
thing that our function needs to do is just this line. So what you do is you apply a concept called partial overriding.
Okay.
Partial overriding means um, using the base class function. You're overriding.
Okay.
So you call it here, and then you say on top of that, I just want to do this. What you do is you go um, item print details like this. So this is going to
Mhm.
call the function, which is the base class print items, which is going to print all those three lines. And then all we do is we then just go ahead and print our vendor.
Vendor.
So the end result of this function is that it's going to show the this, all of
Yes.
this, plus
Plus
the vendor
vendor.
name. Yes. Yes. And that's it. Sorry, that's our function, right? Just
Yes.
do a bit of some. I love to get things cleaned up quickly. ID is a number, item, integer. Okay, perfect. So let's go to vendor. If we are using, if we keep using your IO stream here, then this has to be dot to std to standard string. Okay, like that. That's partial overriding, right? So whenever you override a function, there are cases where you can use your base class function and simply modify its result or add on to what it's already doing. That's partial overriding, which is what we've done here. Okay. The rest of the stuff, I've used your method for printing, which is fine. Another way of also printing here is you can use, I should include Q text stream if you don't want to use IO stream. And then what you then do is you can define your text stream like Q text stream. You can go C out, then you go STD out. And then instead of using the standard C, C++ C out, you can then just use your text stream C out, which is C out. So you can just do it like this, C out. Then you can just go vendor dot get name, and you don't have to, sorry, you don't have to always cast to a standard string. Q text stream understands a Q string. So that's one way you can print items to the console if you don't want to go with your base C++ stream, okay? And I think I'd recommend doing things this way, okay? But anyway, that's just something not important right now. Right, so that's our print details function. We've done the overriding and we are done. Now, we want to move on to a concept which is very important. If we go back to our question here, it then says that's your implementation details. We needed to string method in vendor and in store item that I think we did. No, we didn't. Did we do a Q string here in store item? No, we didn't. Okay. So the toString function is the one that returns a concatenated version of all your member variables. So it would show you if we are in, okay, the question says, we needed a string version in vendor and in store item. Yes. So if we go back to vendor, here, there's our toString function. I think here we did it. Yeah, we talked about this syntax for building a string. In store item, you also want to do the same thing. The challenge is that in store item, what we want to do is it should return a string representation of the object state in a readable format. For store item, implement two versions of toString, one that only returns the item details and another that also includes vendor details based on a Boolean parameter. So this toString version that we need should have a Boolean that says, should you print vendor or not? So if it's true, we print vendor. If it's false, we don't print the vendor. So if we go back to store item, we can then say, let's have our toString here. So let's go Q string toString. There it is. We can then, it should take a Boolean show vendor, maybe something like that. And then we go here, refactor, add definition. Cool, here it is. Now we can say if show vendor, then we should include vendor details. Else we should just print the item stuff, right? Now, item doesn't have a toString function, right?
Yes.
If it had, we could just call the toString function of item and then extend it to also cover vendor details. But in this case, we don't have a toString, which means we need to call these functions to get the ID, the price, and the name of the item inside store item. So we can build our string here and go, let's do it like this so that it's easy. Let's go Q string result equals Q string, and then it's going to show the name of the item. It's going to show the I forget these things. It's name, ID, name, price. Okay, so let's start with the ID maybe. Let's make this the first one, name, the second one, price, the third one, like that. And then you can do the usual .ag. This would be get ID, like that. That's the function we need to call. Now you realize that I'm just calling the function get ID as if it's part of this class. Why? Because it extends item. So store item is, like I said, a combination of item plus store item. So inside store item, because we are extending item, it means all these functions are as if they are also inside store item. So it's like your compiler goes and copies all of these things and dumps them here for you. But just because you've done this. So you can just use those functions.
Yeah.
So
Okay.
so I can just go get ID, I can go get name, and finally I can go get price. Right. So this builds my result. So obviously, if I'm not showing vendor, I can just return my result. So I can just go here. If show a vendor, then do that. Else, just return the result. So here, I'm going to return result and the vendor. So I can just return a Q string that looks like this. So here, I'm going to show this string here as the first argument, like that. Or I can just use the .append function to append to this string. I could have gone like result.append, which means I'm adding on to this string here. And I'm going to append another string, Q string. And here I just do vendor. So I can go vendor name. Then I put that as the first thing. What else do I need in vendor? ID name address. Okay. Vendor ID, vendor name. Sorry. And then vendor address, which is going to be number 3. And then just go .ag vendor get name. Where's my vendor? Store item. Inside store item. Yes, it's vendor. Here we go. Where's my vendor? Get ID, get name, get address. Okay. Get ID. Okay. Sorry. Missing a dot here. Yeah. Then .ag vendor .get name, and then .ag vendor .get address, like that. Why is it not happy? Something here is not very happy. There you go. Perfect. So this will do so if you say show a vendor, it will just return this string. If it doesn't hit this one, it just returns this one. That's my string function inside store item, right? Okay, let's go back to so we've just done it to string function in store item. This to string function is not in item, which is the one that we are extending. We'll talk about that. But if we come back here, it's a console application. Your console application should prompt the user to enter details for a list of items and their corresponding vendors. After entering the details, the application should display the information for each store item using the toString method, first without vendor details and then with vendor details. It should also demonstrate the use of get vendor name for each store item. Okay. So at this point, we just need to where is get vendor name? Oh, it should show, yeah, vendor name is shown here in the print details function. So in our main function, this is where everything comes together now to test our application. So what we want to do is prompt the user for item details, and let's just call for item and vendor details, right? Once we've got these details, we want to create an item. Yep. We also want to create a store item. Let's print item details. Let's print store item details, right? What else do we want to do?
You also want to call it to show everything.
Yeah, so
right?
this is okay, let's using the print details function.
Okay.
Let's also do that here. This should show the vendor, right?
Yes.
Also want to call the toString function, store item, right? With a false. We also want to call the string function of store item with a true, right? So you just gonna be testing our functions here, nothing much. That's all we need to demonstrate, and that's what they are asking for here. Okay, so the main reason for just one sec, for your main application is to simply demonstrate or test that your classes are doing exactly what they should do. That's all. And
Okay.
so if we come back here, there we go. We want to, so the reason why I've listed this is because there's going to be a lot of code here, and I want you to keep track of what we are doing and why we are doing it, right? So let's start by including our classes, item, or we can just include store item because then it also includes item. We also want, I think that's the only thing we need, store item. Yeah, let's also include item, but it's fine. So let's also include QString, maybe. I think that's all included. Let's include QTextString, which is what we need to get user input. So as usual, you can just define a QTextString here. stdin. So you can use this for getting user input. So prompt the user for item details. So we can just go, let's also go with cout. That. So we can say cout and the item name like that. Yeah. So
how many items the user input, or does it not matter?
you can just you just do one because we just want to demonstrate that this is doing what it should do. If you want to do two, it will be redundant because you just want to be repeating this. So in this case, you just want to demonstrate that all your functions are working. So just one item is enough, one store item is also enough, and one vendor is enough. So and there's going to be a lot of code here. The reason why I'm thinking is cout doesn't show this unless you then go, unless you flash the output. So you go cout dot flash like this. But sometimes you can force it to flash if you just go end line. So I was just thinking, let's do it like that. It's fine. So you're gonna enter the name, let's start with the ID, item ID, then the price, And then you're gonna do the
Address.
yes. No, item is just name, I think. Yeah, name. So here
Oh,
item ID. I don't think, yeah, I won't do this because it's gonna take time. I mean, you can play with this if you want. I just want to do three only and stop there. So you can just go, so here we can define an item. That's our item, right?
mm-hmm.
And we can have um int ID, um q string name, and price is what? Price is a double. And then we can have a double price. So here you can go see in ID. Here you can go name is a Q string, see in name. So if you're using a Q text stream, it can just take your input and assign that to a Q string. If you're using C++ IO stream library, then you cannot, you would have to create a Q string from a string, but you can still do that if you want. But this is just easy because it's all cute. Price, then we can go see in price, and then for us to make an item, remember an item here is a constructor, okay, which takes nothing, that's fine. There's a lot to discuss here. Okay. Let's just define an item here. Now we can set our values. We can go item.set ID to ID, item.set name to name, item.set price to price. Okay. So we've got an item. You can do the same thing for vendor. As you can see, vendor needs a name, ID, address, all of that. What I'm going to do here is cheat vendor v. I'm just going to go v dot set address. I'm just going to go here vendor address just for the sake of time. V dot set name, vendor name, and then v dot set whatever ID. I'm just going to do 111 like that. But you'd have to also get this information from the user in the same way and do your sets like that. Yeah, I'm just hard coding it because yeah, it's the same thing. So I've got my vendor, I've got my item. Okay, create an item. So that's what we've just done here. I could have maybe to make it all consistent, put my item together with this code. There's my item and there's my set. Then we said, okay, this is creating a vendor. We need to set this vendor on this item, right? No, this one doesn't have a vendor. Oh yeah, that's fine. Okay, that's good. That's okay. So we need to create a store item. So that's where we need a vendor. So there, store item, S item, for example. Just want to hard code again here. So according to the question, you would have to go see out and get all that information and then do this. For me here, for the sake of time, I'm just going to hard code these values. S item dot set ID. Let's go 222. Our store item dot set name is going to be store item. And then S item dot set price is going to be 100. That ID is a number. Okay, it's fine. 20. Then if we go to store item, you see that we don't have a way of setting this vendor on store item, right?
Yes.
Which means we missed a function either as part of the question, they didn't specify it, or we just didn't do it. Oh, there it is. We didn't do it. Vendor details should be set using a separate method, set vendor, which takes a vendor object as a parameter. So let's do that quickly. That's something we had not done. It's a normal set function, so you can go void set vendor gets a vendor fee. And as usual, it's a set function. So we can say vendor equals fee like that. So that's how we set our vendor. Okay, perfect. So we can go back to our main and now we can set the vendor. So now we've made this vendor here. We can go s item dot set vendor and we give it our vendor there. So what we do here is we create a vendor. And then we give our vendor to our store item. Am I still with you?
Yes.
Okay.
Yeah. Yeah. You're still with me.
Okay. So what we've done, remember we've got three classes, an item, and then a store item, which extends an item, and the store item has a vendor, which is this guy.
Yes.
So in our main function, all we've done is we've said, let's get this information from the user, and let's use this information to make an item by calling our set functions. Same thing here. Let's make a store item and let's call our set functions.
Yes.
And let's make a vendor. Let's call our set functions. And let's take this vendor and set it as the vendor for store item using this function. So the set functions, you use them to set values for your class, the actual values, which is what we are doing here.
Yes.
The only way to check that our functions are working correctly is if we try and print. So let's call the print details function of item, right? So let's go item dot print details. We expect to see item details here, right? So let's go see out, just so that it makes sense. Item details are. Okay, then we call this function. So we should be able to see our item details. And then we're going to do the same for store item, print details, and so forth. Let's see if this is working. Oh, multiple definitions of C out. Okay, didn't see that. Okay, let's go back. We have, let's go to store item. Yeah, I think it's complaining because of that. Let's see. Okay, that was it. Okay, perfect. Now let's run. Okay, item ID. Let's go 11, enter name. And I'm just go item name. Okay, item details are product name, item, product ID, 11, price 0. Yeah, because I'm not entering the price. But the name is only, it's cutting it off. It's not getting the whole name. It's fine for now. We should actually go see in dot. Yeah, if you just do it like this, it will stop at the first space. So you might want to go see in dot read line, I think. Something like that.
Okay.
Wait. That's how you read if there is going to be spaces. I think you can do it like that. Price.
Okay.
What's going on with my price here? See in dot get price. I'm doing that. Oh, because it's a string. Oh, no, it's a double. And item price. Okay, something weird going on, but anyway, let's see. Let me just check what's going on. It says end item ID 1. Name price. This is gonna take us forever. Okay. I won't have time for this right now. Let's just quickly do this. And then price, and then I think it's skipping price anyway. Let's see. Yeah, there's a thing around these streams and how they read and all of that. So it might ingest extra characters and all of that. Item ID, one, name, price, 43. Oh, there you go. Now it prints. Okay, that's fine. So that means your print details function is doing its job, doing what it should do. Fine. So we can go ahead and print details for store item.
Yes,
Yeah.
and the vendor.
Yeah, so you can go s item dot print details. This should always print the vendor. This one, the print details function. I don't like having to put all this input here. So just for the sake of testing, I'm going to remove all of that. You can play with the program and do the inputs and all of that, but I'm going to hard code all of this so that we don't have to enter these things all the time. We run it. Name, set price, 56 ID 1. Okay, cool. I don't have to enter anything now. So print details should print the vendor. This should print store item details. Oh, where's this one? Okay. Store item details are sitem.print details, which is fine. So if you run that, we should see both the vendor stuff. Let's see. Okay. Yeah, there's the vendor or store item details, which means that's working correctly. Now let's test the toString function of item. So I'm just going to use this here. Cout item details using toString. No, store item details. Store item details using toString, and we want to go cout s item dot toString false. So this is, we're going to use false here. And I'm going to repeat this and test this with true. So this is going to use true. And I'm going to put true here and see if our code is doing what it should do. I'm going to run it again, see what it looks like now. Okay, there we go. Store item using toString false, that's the item. Store item using toString true, blank. So this function is not working correctly. You see that?
Yes.
So you can go and figure out why is it not printing if we use true here. So you have to go to store item and say, if we put true here, it should do this, right? Yeah. Oh, what is it? What is this warning? Ah, it doesn't matter. Result.append. Oh, sorry. It's because of this end line. That's what I said earlier. If you don't flash it, it won't show it. So this will force it to flash. Or you can just do, if you want, you can just flash the stream. So you can just go cout.flash. This is what causes it to actually push the actual result to the console. So here it wasn't just showing it. That's why. So I think if we run it now, it should be able to show our result. There we go. Yeah. So with true, it goes ID name, price, vendor name. Ah, see, that's repeated twice. Oh, because that's what I used for the vendor name. Okay.
Yeah, you used vendor name.
Yeah, I used this. Okay, that's fine. Yeah. So this means your functions are working. You've tested all of them. Only that this question required you to actually get all of this from the user. And I was just too lazy to do that. But otherwise, yeah, that's classes for
Okay.
you. So this question is good because it introduces you to classes using a very simple solution, which has got three classes. Your item with your get and set functions, your store item with your toString function, your print details, which we override, partially override actually, your set vendor, and yeah, that's inheritance. Now, as far as this question is concerned, then you are done, right?
Yes.
But because you understand this solution, we are going to
Mhm.
extend this solution to then discuss a concept called polymorphism, right?
Okay.
Now,
Yes.
what's going to change is you were dealing with a very simple and a very small solution here, right? You're going to
Mhm.
realize that moving on to um, the next section of this course, which is inheritance, we're going to cover more classes, but same concept.
Okay.
And what I mean by that is, let's say we look at this diagram here, right?
Yes.
And we go back to what we are looking at right now. You, what we have at the moment is item. Come on. Item here. Then you have store item here. Then you have vendor here. That's exactly what you're looking at. If we draw these this UMO diagram, it looks like that, right?
Yes.
This arrow that you see here with a triangle represents inheritance.
Okay.
This diamond that you see here represents aggregation. Sometimes composition if it's solid like this. Then this would be composition.
Okay.
So we are always going to be looking at these types of relationships. Number one, inheritance. Number two, aggregation. Number three, composition. Inheritance, there. Doesn't matter which direction. It's a triangle. Aggregation, there. Composition, there. Solid. Clear.
Yes.
We're going to
Yeah.
go into the details of what are these three relationships. What inheritance, I think we've discussed it. That's what we've been talking about.
Yes.
We are extending a class. But when it comes to these two, we are going to go into more details around what is aggregation, what is composition. It's not difficult to understand. We'll get there. But if we look at this UMO class diagram, this solution is simply this. Item being inherited by store item and item as a vendor inside it. That
Mm.
right? Perfect.
Yeah.
Actually, I am wrong here. Sorry. I am very wrong. Our diagram actually, let's remove that. Vendor is inside store item, not in item. Sorry. So that means we should do it like that. vendor. Like that. And that's our aggregation there. Okay, that's our diagram. Now, we are identifying two types of relationships here: inheritance, aggregation, or composition. Now, if you go here, nothing has really changed. You have your registration here. And what is this?
Which one? This one, that's pointing at registration.
Yeah.
That is inheritance.
Inheritance. Good. Well done. So that means previously we had item and store item. Here, the only difference is we've got not just one, but two classes, both inheriting from a registration. So you've got a student registration and a guest registration, but they both inherit from a registration. The concept is exactly the same. Now, I'm going to ask you another question. What do you call this?
That is like the inheriting, right? That's inheritance.
Yeah.
Or is it overriding?
Yeah. If I underline this function here, what is happening here?
Calculate fee.
Yes.
I'm not sure I understand the question.
Yeah, we've got this calculate fee function in registration, right?
Yes.
But we see it again in student registration and in guest registration.
Oh, yes. It's being inherited from registration.
And the word we should use is?
Overriding.
Overriding. Same goes for the toString function. You see that?
Yes.
So in other words, we can say student registration and guest registration are overriding calculate fee and toString because it's there in the base. We see it again in the subclasses.
Yes.
Yeah.
Okay.
Person is like vendor. Inside your store item, you've got a vendor, right?
Mm-hmm.
Inside your registration, you've got a person.
Yes.
That's what's going on here. So this side relationship that you see between a person and the registration is exactly the same as what's going on here. Only that it's composition, but it's the same thing. What it means that if you go inside store item, you're going to find a vendor, isn't it?
Yes.
Under private, yeah. So if you go inside a registration, you're going to find a person.
Person.
Under private, yes. That's this.
Okay.
This we'll talk about at some other time. This part.
Okay.
But the rest of this diagram is exactly what we've just discussed. Only that we've got more classes involved with more member variables and more functions.
Okay.
Right. So what I want us to do is we want to come back and do these classes here. But before we do these classes, I want us to understand everything that's happening here, but just using this same example that we've been using, this one.
Okay.
We've covered inheritance. We've covered this part where inside store item there's a vendor. There's nothing new there. That's exactly what's going on here. Inside registration, there's a person. So that if you can understand it using this example, we're going to take that knowledge and apply it here. Exactly. Nothing changes. Only different classes, different functions, but same thing everywhere. Clear? So what we want to do is discuss the concept of polymorphism, which we will still discuss here, but we want to do that using this example. Once we understand polymorphism using this example, we'll come back here and we can redo this question again from scratch. Just do this class, do your inheritance, implement all these functions, test our functions. And then after that, we can then worry about this part here. This is just a list of your registrations, which is not covered by this simple example. If we had to include this part in our exam, actually, let's do that. Let's then talk about this part, but using this example. So in other words, what we're going to do is end up having, hello, I was hearing you, but I think you lost me somewhere.
Yeah, my network glitched, but I'm back. I'm so sorry.
No, it's fine. It's fine. It's fine. So what
Yeah.
I was saying is what we are going to do is before we move on to this diagram, which is like massive and all those things going on, I want you to
Yes.
understand everything that's happening here, but using this example. So if we include this part, our diagram here is going to look like this. We're going to have an item list here, and our item list is going to inherit from a queue list of type item. Now, our simple example is exactly the same as this diagram, which means everything we are going to discuss using this example here, you are simply going to take that knowledge as it is and apply it here and repeat everything. You're going to repeat the inheritance, the overriding of these two functions. We'll talk about we'll talk about the list. So before we then move over to this diagram, we're going to discuss UMO class diagrams. How do you read and interpret this diagram? What is this? What does it mean? What's going on with all these hyphens and pluses and the syntax being used here? We are going to discuss that. Interpreting a UMO diagram is very easy. But before we go into UMO class diagram interpretation, I just want you to understand the whole concept of inheritance and polymorphism. And then when we move over, once you understand all of that and it's all making sense, when we move over from this example to this here, I then need you to be able to look at a diagram and be able to interpret it. In other words, you can, there's a one-to-one translation or mapping between a UMO class diagram and a class. In other words, you can look at a diagram without anyone saying anything. This diagram is actually enough for you to go in Qt and define all the classes. That diagram has literally everything you need to do all these class definitions. That's what a UMO class diagram tells you. So for now, we won't worry about the interpretation or how to read a diagram. We just want to finish off understanding the inheritance that's happening between item and store item, an item having a vendor. And now we are going to introduce the concept of polymorphism. And then from there, we are going to introduce a class called item list, which is a list of items. And we are going to add 2, 3, 4 items to our list and maybe show all of them or calculate the total price for all those items, all those little things, which is what you see being done like here, calculating the total fees for all your registrations, deleting all of them, adding a new registration. We're going to be adding a new item, calculating all the price for the items, I mean, the price for all the items and all of that. So that's inheritance, that's polymorphism. So we'll get to this example and we'll discuss everything around it. And then from there, you can do a lot of other examples, like this is registration. You can do celestial body and the star, that's just inheritance. You can do assets. And I'm going to give you access to the portal. We've got plenty of videos that address these different types of UMO diagrams, and they do the implementation from scratch. It's all now just going to be repetition of the same concept, just being applied to different types of classes. Like here, you've got assets and types of assets. It's all inheritance. You've got overriding going on with the value function. And then, yeah, we'll just take it one step further, and then eventually we're going to talk about the concept of abstract classes. So there's quite a journey that we need to travel. And I want to take a very small, very small incremental steps to getting to that level. And we are going to begin with this little example of ours, cover every single concept. Then we'll go to here, which is now registrations. And then once we are done, we'll take things further and go to the assets example, which takes things one step further by introducing what are called abstract classes. And then that will be all the inheritance you ever need to know. Okay.
Awesome.
Perfect. Okay. So I'm going to send you, remind me this solution so that you can just play with it if you need to. Otherwise, that's it. Cool. All right.
And how soon will this video be accessible?
There's a